Write each expression in one or two other ways. Number one is 5 times W. Well, we can always switch the factors, so it could be W times 5. It could be 5 groups of W, or W groups of 5. Or we learned in algebra that we could also put the variable right next to the whole number, and that implies multiplication. So we could write 5W. You cannot write W5. Remember that the whole number has to be listed first, the variable listed second. Number 2, V times 15. Well, we could have 15 times V. We could have V groups of 15, or 15 groups of V. You could also write 15V. Number 3, x divided by 3. Well, we learned in algebra that another way of writing x divided by 3 is saying x over 3. So that's one way. And the other way we can write this division expression is by changing the division problem into a multiplication problem. And remember, back when we were doing fractions, we talked about how we can keep, change, and flip, or find the reciprocal. So we would keep the x, we change the division sign to multiplication, and we flip the 3 over 1 to 1/3. So another way we could write this expression is x, or 1/3 times x, or x times, make that x bigger, x times 1/3. Now, just to show you how that works with whole numbers, let's say that x was 12. Okay, so we have 12 divided by 3. Again, we could do the keep, change, flip. We keep the 12. We change the division sign to multiplication, and we flip that whole number, 3 over 1, to 1/3. And now, if we were to multiply, we'd have to put that whole number over 1, and 12 times 1 is 12, and 1 times 3 is 3. So essentially, we still have our division problem, right? 12 over 3, or 12 divided by 3. So that's why x over 3 is the same thing as, and I'm going to rewrite it so we can see it clearly here, x times 1/3. So you could write it either way. Number 4, 1/4 times y. Okay, we could, because it's a fraction, we need to, let's try to get it back into a whole number. So if we were to put y over 1, 1 times y is y, and 4 times 1 is 4. So we could do y over 4. And we know that also means that we could write that as y divided by 4. Number 5, z plus 4 over 5. Well, we know that when you have an amount over another amount, that's signaling division. So we could say z plus 4 divided by 5. That would be another way to write the expression. And based on the keep, change, flip, we could keep z plus 4, change our division sign to multiplication, and flip that whole number, 5 over 1, to its reciprocal of 1/5. So we could say 1/5 times z plus 4. Number 6, 1/2 times a minus 7. So again, this is like taking half of a minus 7. So the first thing we want to do is we put a over 7 over 1, and then we could multiply. So 1 times a over 7 is a over 7, and 2 times 1 is 2. So we have a over 7 divided by 2, or over 2, and that signals the other way we could write this, a minus 7 divided by 2. The directions on the next part say, write an expression for each of the following. Add b to 9. Okay, so if our starting number would have to be 9, and we are adding b to 9. So the algebraic expression would be 9 plus b. Number 8 says subtract 4 from b. So our starting value has to be b because it says subtract 4 from b. So the algebraic expression would be b minus 4. Number 9, subtract b from 10. Well, our starting number would have to be 10, and we're going to subtract or take away b from 10. So 10 minus b is the expression we would write. And number 10, multiply b by 3. So 3, we could say 3 times b, but we know in algebra that when we're multiplying a variable times a whole number, we can simply list the variable next to the whole number. So it would be 3b. Number 11, multiply 7 by b. Well, 7 times b, but again, in algebra, we list the variable right next to the whole number. So 7b implies multiplication. Number 12, divide b by 5. Well, b divided by 5, but we know in algebra we would list that as b over 5. So b over 5 would be the expression. Number 13 says half of b. So you could say half of b, but we could list that as b, right? Because 1 times b would be b, and 2 times 1 would be 2. So the best way to write that would be b over 2. Sometimes it's helpful, though, to write that out. So saying half of b helps you to see that it would be written as b over 2. Number 14, add 10 to b, then divide by 7. Okay, so let's deal with this first part. Add 10 to b. So 10 plus b. So that's the first part. Then I need to divide that amount by 7. So instead of just writing divided by 7, we're going to put 10 plus b over 7 because that shows division. Number 15, multiply b by 6, then subtract 11. Okay, so let's do this first step. Multiply b by 6. Well, we could say b times 6, but we know in algebra that we would list that as 6b. And the second part then says, then subtract 11. So I need to take away 11. So 6b minus 11. And number 16 says divide b by 3, then add 8. So divide b by 3. So b over 3, then add 8. An equation in terms of x for each of the following, then evaluate the expression when x is equal to 18. Okay, so it says John is now X years old. So 17 said the age of his brother, who is 5 years older. So if John is X, his brother would be 5 years older. So X plus 5 would be the expression. And now let's substitute 18 for X and solve. 18 plus 5 is 23. Number 18, the age of his sister, who is 3 years younger. Okay, so John's age is X. His sister is 3 years younger. So we'd have to take away 3 years from John's age to find his sister's age. So the expression would be X minus 3. Now let's substitute X for 18. 18 minus 3 would be 15. So the age of his sister would be 15 when John's age is 18 because she's 3 years younger than John. Number 19, the age of his aunt, who is twice as old as him. Okay, so John is X, and if his aunt is twice as old as him, it would be 2 times his age. So we would say 2x, or 2 times x. And let's substitute 18 for x. So 2 times 18 would give us 36. So his aunt's age is 36 when John's age is 18. Number 20, the age of his cousin, who is half his age. Well, half of x is really saying half times x. So if we put x over 1, we get x over 2. And now let's substitute 18 for x. So 18 divided by 2, well, 18 divided by 2 is 9. So his cousin is 9 years old when John's age is 18. This next part says, write an expression in terms of n for each of the following. Then evaluate the expression when n is equal to 24. So here again, we're going to be first writing an expression, and then second, we're going to evaluate it or solve the expression if n is equal to 24. So it says there are n strawberries in a carton. So we need to find the number of strawberries left after 6 pieces had been eaten. So here are this unknown amount of strawberries in a carton. And if 6 are eaten, we're going to take those 6 away. How many would be left? Well, let's substitute 24 for n and solve. 24 minus 6 is 18. So when there are 24 strawberries in a carton, after 6 have been eaten, there will be 18 left. Number 22. The number of strawberries each child gets when the carton of strawberries is shared equally among 4 children. Okay, so we have the unknown number of strawberries, n, and we're going to divide that among 4 children. So n over 4 would be the expression. And now let's evaluate that expression when 24 is substituted for n. So 24 divided by 4 is 6. So when there are 24 strawberries, you divide them among 4 children. Each child will get 6. Number 24. The number of strawberries each child gets when 1 carton and 11 strawberries are shared equally among 5 children. Okay, so the number of strawberries when each child gets when 1 carton, and so that would be n, because we don't know how many are in there, plus 11 strawberries. It says and 11, so it's a whole carton and 11 more strawberries. So n plus 11. These are shared equally among 5 children. So we're going to divide them among 5 children. So our expression would be n plus 11 divided by 5. And now let's substitute 24 for n and solve or evaluate this expression. So 24 plus 11 is 35, and 35 divided by 5 is 7. So each child would get 7 strawberries, dividing a carton, which would have 24 in it, plus 11 extra. Each child would get 7 strawberries.